it will gives you ammonium hydroxide. Okay, ammonia. So if you don't know the formula of ammonia, so how will you able to react? How will you able to write the reactions? So if you don't know the formula, so this is very important for every student that he or she must know that how to write the chemical formula of the compound. And even if you know that nitrogen and hydrogen, when they are combining together, what formula they are going to form? Like for example, nitrogen, if they are combining with hydrogen, which formula they are going to form? So that is important, that what is the formula when nitrogen and hydrogens are going to combine. So, and there are some compounds that have their common names. So we are just going to learn the names of some common compounds. We are just going to learn that what is the formula of the compound that when hydrogen and nitrogen is going to combine. So for that, what we are going to study here is today, that is the valency of the elements, valency. And before learning the valency, we must know the atomic number of every elements. Okay, so here for sure I'm just writing the numbers, the atomic number of the first 20 elements. Like for example, hydrogen has atomic number 1 and its valency is H plus 1, means we have its valency is 1. Then we have, that is we will say that helium has valency 0. Helium has valency 0. Atomic number is 2, but helium has valency 0. No charges over it. Then we have lithium. Okay. Lithium has atomic number 3. This is atomic number. And it has, are you there? Are you getting
Yes,
this
sir.
one, Mariam?
Yes, sir.
Okay.
Yes, sir.
Okay. Okay. So if I'm talking about that lithium has valency 3, so its atomic number is 3 and it's electronic. I'm just going to write here electronic configuration also, so that you can understood more betterly that how what is the formula when these elements are going to combine and how to write the chemical formula of the compound. This is very important. Okay, along with this one, this chart is important that every student must know and must know the valency of these elements. But this is very important that there's some trick that how can you learn the valency of the elements. Okay, there are some elements that you can memorize their valency directly, and there are some that you need to memorize. Okay, so this is lithium. Lithium has electronic configuration 2, 1, atomic number is 3. So it will donate 1 electron. So the formula for this lithium, for the valency of this lithium is +1 because it will donate 1. Now we have beryllium. Okay. Then beryllium is actually going to have atomic number 4 and its electronic configuration is 2, 2. So it will donate 2 electron in order to attain the stable electronic configuration, that of helium. Okay. So it will donate 2 electrons. So when it will donate 2 electrons, it will acquire a charge of +2. Okay. Similarly, beryllium, then we have boron. Okay. So boron has atomic number 5 and its electronic configuration is 2, 3. So it will donate 3 electrons. It will not have 5. It will donate 3 because the second shell can have maximum 8 electron. Everybody know this 2, 8. The second shell can have maximum 8 electron. So here it cannot have 5. So it will donate 2. So boron will have, okay, +3 oxidation state or +3 valency. Boron. Okay. After the boron, we have the next one is boron. After the boron, we have carbon.
Carbon.
After the carbon, we have 6. And here we have electronic configuration 2, 4. And carbon is a state where it can neither gain 4 electrons nor it will lose 4 electrons. So it will share. Covalent bond is formed that we're going to discuss. The covalent bond will form. When the covalent bond is going to form, then it will have carbon as +4 valency. Okay, we'll write here +4 just because carbon is giving its 4 electron. But don't think it is permanently giving, it is sharing. So but we'll write +4 here. Okay. Next is after the carbon, we have nitrogen. Nitrogen, atomic number 7, electronic configuration 2, 5. Now it will not donate 5. This time it will not donate 5. It will gain 3. Because donating 5 electron is very difficult. So it will not donate. Here, in this case, it will not accept the 5. It will donate 3. In this case of boron, it will donate 3. Okay. And in this case, it will accept 3. It will accept 3. So if I ask you that what is the formula of the compound when boron and nitrogen are going to combine? So it will be Bn. Boron will donate 3 to the nitrogen and nitrogen will accept. So it will be Bn. You can say. So simple is that this nitrogen will accept 3 and boron will donate 3. So they both are compatible with each other. Okay. So in this case, the valency of nitrogen will be -3. Since it will gain the 3 electrons, so its valency will be -3. And then after the nitrogen, we have oxygen. Oxygen has atomic number 8. Electronic configuration is 2, 8, 2, 6, 2, 6, and it will gain 2 electrons. How many electrons it will gain? It will gain 2. Not donate 6. It will gain 2. Why? Because donating 6 electrons is very difficult. So it will gain 2 electrons. You understood? Understood?
Yes, sir.
So it would be, the valency of oxygen will be -2. We'll write -2. Okay, because it will go against 2. And similarly, that of fluorine. Fluorine has atomic number 9. So it would be F, electronic configuration 2, 7. So in order to attain stable electronic configuration, again, it will gain 1. It will gain 1. So it will be F -1. The fluorine valency would be -1 because it will gain 1. Now the next we have neon. Neon has atomic number 10. Its electronic configuration is 2, 8. Now it's completely filled. Now it will not gain any electron, nor it will lose an electron. So in that case, the neon is going to have 0 valency. It will not going to have any charge. It will have 0 valency. Similarly, the helium and neons, and it is also going to have 0 valency. So when an element is going to have 0 valency, then in that case, we will simply say that this element is going to, simply say that this element which is going to have 0 valency, okay, that is considered to be as noble gases. We will consider it as noble gases. So those elements that have 0 valencies are considered to be as noble gases, and other elements wants to attain the stable electronic configuration to that of that element, to the same of that element. Like every element, the previously, up to this will donate 3, this will donate 2, this will donate 1, it will accept 1. So they are all up to here, they are all want to have the electronic configuration to that of helium up to here, and from here they all want to have the stable electronic configuration to that of neon. You understood, everybody?
Yes.
Okay. Next, if I talk about the, again, if I move to the next part here, is that in the next part we have, after the neon, we have sodium. Sodium has electronic configuration 281, and sodium has electronic configuration 281. Again, it will donate one of its electron. Okay, it will donate one of its electron. Why? Because its stable electronic configuration is 2, 8. The nearest noble gas is 2, this one, neon. So sodium, what will sodium do in order to attain the stability? It will donate one of its electron. So it will donate one of its electron. It will have Na1 positive. 1 positive. It will be considered as Na1 positive because again it is creating the same condition as that of lithium. Lithium will donate 1 electron in order to attain the stable electronic configuration to that of helium. Similar is that for sodium also. Sodium for also. Okay. And the next one is, if I talk, next one is magnesium. Magnesium has atomic number 12. Mg 2 positive, again because it will have 282 electronic configuration, so it will donate 2 of its electron in order to attain the stable electronic configuration that of neon. So it will donate 2. Similarly for aluminium, next is aluminium. Aluminium has atomic number 13. It has valency Al3 positive. It has electronic configuration 283. Again, it will donate 3 to attain the stable electronic configuration. Now we have, next one is silicon. Silicon has atomic number 14. Again, we have Si silicon, and it is having the same condition as that of carbon. Having 4 electron in its outermost shell. Carbon also has 4 electron in its outermost shell. Now it's a neither it will like to have the electronic configuration to that of helium. Okay, not it is not donating permanently, it is not accepting, so it will share. So similar that of silicon, sorry, that of carbon. Silicon has oxidation state +4. +4 means valency 4. Next one, after the silicon, we have phosphorus. We have phosphorus, and in the phosphorus, we have atomic number 15, P, and it has electronic configuration 285. So it will donate. What it will do? It will donate. Neither it will donate. No, sorry, it will gain 3. Like in the case of nitrogen, 2,5. Valency is -3. Similar is that phosphorus, -3 valency. Then after the phosphorus, we have 16, sulfur. Sulfur, atomic number 16, electronic configuration 286. That similar to that of oxygen, 2,6. So it will gain 2. Similar, the sulfur will also gain 2. So that will have S-2. S-2. Okay. The next one is after the sulfur, we have is 17 is chlorine. Chlorine, 17, 287. So it will not, sorry, we have to write here, 287. 287. So here it will be chlorine and it will be Cl-1. Why -1? Because this time it is gaining 3 electrons. So it will be -3, gaining 2 electron minus. Okay, so accordingly they are gaining. So the charge, if they are losing the electron, they will be acquiring the positive charge. If they are losing the electron, they will be considering the negative charge. Similar, that of after the chlorine, we have argon. Argon will have 18, and this is argon, Ar, and that would be 288, dear students. And the argon is going to have 0 oxidation state because it is completely filled as that of neon, 28, and the argon is 288, completely filled. Then after the argon, we have potassium. We have potassium. Okay. Potassium is 19 and it has formula K, electronic configuration 2881. Because the outermost shell cannot be. We know that the third shell can acquire more than 8 electrons. Third shell can acquire more than 8, means 18 total, 18 electron. But if the third shell is the outermost shell, then it cannot acquire more than 8. Any outermost shell cannot have more than 8 electrons. So if you write it 289, then it will be the violation of the rule. Bohr-Bury scheme, that if you write 289, then this will become outermost shell, and in this outermost shell, it is acquiring the 9 electron, which is incorrect, which will be considered. We know that third shell can have 18, but according to Bohr-Bury scheme, firstly, the fourth shell will fill. Fourth shell will have 8, then it will start having 9, 10, 11, 12, so on. So we'll learn this one. But here, right now, it is having 281. So it will donate 1 electron to have the stable electron configuration to that of argon. So it will again donate. So it will donate 1. And similarly, that of calcium, that are the first 20 elements that I'm writing here. Calcium, it is 20, Ca2 positive. Okay. Then it is 2882. So it will donate 2 electrons in order to attain the stable electronic configuration to the nearest noble gas, that is argon. Argon, dear students. You understood, everybody? Tell me fast. Tell me.
Yes, sir.
Okay. Okay. So now moving to the next part here is that that if I'm saying that any element is going to make some formula, if it is combining, okay, like for example, calcium and oxygens are combining together. So you know that calcium valency is 2, means calcium's outermost shell electron is 2. So it wants to donate 2 electrons. So it is 2 electrons here. And oxygen 1, 2, 3, 4, 5, 6. Oxygen has 2,6. I told you that only the outermost shell electron participate in the bonding. Only the electron that are present in the outermost shell participate in the bonding. So what is going to happen here is oxygen has 2,6, okay, electronic configuration, and calcium has 288, 2 electronic configuration. It wants to have 288 electronic configuration, 288 electronic configuration, and this oxygen wants to have 2,8 electronic configuration, because the nearest noble gas of calcium is argon and that of oxygen is neon, 28 neon. So what it will do? It will donate 2 electron to this one permanently. So when it donates 2 electron to it permanently, what is going to happen? This calcium will become Ca2 positive and oxygen will become CO minus 2. Why? Because it has accepted the 2 electrons and it has donated the 2 electrons. This type of substance that, or the atoms that acquire the charge by losing or gaining the electrons in chemistry are called ions. What we called it? Ions. Ions, okay? The atoms are electrically neutral. Atoms don't have any charge. But when they lose or gain electron while they are making bonds, when they are combining with other elements, they'll either lose electron, they either gain electron, they either share electrons. Why they are gaining, why they are losing, why they are sharing? Just in order to attain the stable electronic configuration to the nearest noble gas. Why the atom is losing the electrons? Why the calcium is losing 2 electrons? In order to attain the stable electronic configuration, that is 2,8. Why the oxygen is gaining 2 electrons? Why the oxygen is gaining 2 electrons? In order to attain the stable electronic configuration to the nearest noble gas here. So just a minute, I'm just coming in. There's someone at the door. Just a minute. So here it is here the calcium is actually donating the electrons and the oxygen is gaining the electron permanently in order to attain the stable electronic configuration. So if I ask you, what is the valency? Valency is actually the combining capacity of an element. And when an element is going to combine with some other elements, when it is going to make bonds, okay? So when it is going to make bonds, then during that time, dear student, during that time, they either gain electron, they either lose electrons, okay, in order to attain stability. So that's a question, that why do hydrogen exist in the form of H2? Okay, why the oxygen exists in the form of HO2? Why the water has the formula H2O? Okay, why they have these specific formulas? So I just called you that hydrogen does not exist independently. Hydrogen does not exist independently. Just a reason behind it is that the hydrogen has only one electron in its outermost shell. If the hydrogen has only one electron, if the hydrogen has only one electron in its outermost shell, okay, so it will not be stable. So what it will do, it will make a bond with similar to that other elements, similar to its elements, and they both will share one electron here. Like this way, they both will share one electrons and will completes its duplet. Okay, hydrogen completes its duplet like this way. Got it? So they both will complete by sharing one electrons here. Okay, by sharing one electron. Similarly, oxygen, why do oxygen exist in the form of O2? It does not exist in the form of O. The reason behind is that this oxygen atom is having 6 electron in its outermost shell. Another electron, 6, 1, 2, 3, 4, 5, 6. So what they are going to do here is that they will share two electrons, because when they are having 6, they need two sharing, not the one. So they will share two electrons. For some time, this oxygen will have 8 electrons. Just a minute. Okay. For some time, this oxygen is going to have 2 electrons and the another is also going to have the 2 electrons. They both will share two electrons of each other. in order to make bonds and will form, and that's why the oxygen exists in the form of O2, not individual existence of O. That's why we write O2, O2, not O. Why we write O2? Why we write H2? Why we write N2, N2, nitrogen, not N only? Just because they are just sharing. Just like nitrogen has 5 electrons in its outermost shell. 1, 2, 3. So they will 5. If it is 5, then how many nitrogen needs? 3 in order to complete its octet. So they will share 3 electrons. 3 electrons. Okay, so they will bond together like this way. They will share 3 electrons. So they both will have 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8, and 6 and 2, 8. Okay, so that they both are going to have 8 electrons. So this is the reason why hydrogen exists in the form of H2, why the oxygen exists in the form of HO2, why the formula of water is H2O. Why the formula of water is H2O? Simple, that oxygen has only 6 electron in its outermost shell. Like I'm just making here like this way. Oxygen has only 6 electron in its outermost shell. 6 electron. And hydrogen has only 1. Hydrogen has only 1. Okay. So these are the 6 electron. 1, 2, 3, 4. And oxygen wants to have 8 and hydrogen wants to have 2. So this is the 1 electron oxygen will share with this hydrogen and 1 electron will share with this hydrogen. Now for some time, this oxygen will going to have 8 electrons. Like this way. 1 of hydrogen, 1 of this hydrogen. So they will have completely 8. And for some time, this hydrogen will acquire the 2. And this hydrogen will acquire the 2 electrons. So this is the reason, dear student, this is the reason that why the formula of hydrogen is, formula of water is H2O. Why it cannot be HO or H2O2? Why they have fixed formula? Why the compounds have fixed formula? The reason behind is that they can share the particular number of electron, another element can accept the particular number of electron. For example, oxygen can accept only 2 electrons, maximum 2 electrons, maximum 2 electrons. Okay. Now there are one electron. There is an element that can donate only 1 electron to it. They can that it can donate only 1 electron. So how many such element will be required to tell me, Mariam, Arya, Aisha, and Abdul Jabbar? Tell me that how many electrons donor of such donor will be required for the oxygen atoms if it is donating only 1 electron maximum? Arya, tell me that how many, if water is going to form here, then how many oxygen
2.
it will be, how many such hydrogen atom will be required? Only 2 now, because if one is donating, okay, so one, it will donated by this one will be donated by this one. So that's why the formula will be H2O, not H3O, because if how can it 3, how can it have 3? If there is 1 extra, then it will not have 8. The limit will be crossed. Now it is having 8 completely filled. Okay.
So rasa 2.
Yeah. So that's why, yeah, it's okay. Very good. So that's why the formula of water will be H2O only. You understood? Aisha,
Yes,
you
sir.
understood? Mariam, you understood? Abdul Jabbar
Yes, sir.
and other students, you understood?
Yes,
Yes,
sir.
sir.
Yes. Okay. Just done. Okay. Now moving to the next part here is that when we are just writing the formula, it is must that we must memorize the valency. So just there is some tricks that I'm going to here that there can be so many we can say that what we called it in Hindi, rhyming schemes you can say in English. For example, lithium, hydrogen, lithium, सोडियम, पोटेशियम, है, ली, ना, करे, रब, से, फरियाद. Okay. So these elements are not going to come in your syllabus. So they are just leaving this one. You just need to write hai, li, na, kare. So they all are going to have +1 valencies, most of them. Then BE. PEMG, beta mange, car, scooter. This is not going to come in your syllabus, so we are just leaving this. So Be2, Mg is 2, calcium is 2. Okay. You can means there are some that you can memorize it very easily. Okay. Then boron and aluminium has 3. Boron and aluminium has +3. Then Ca, 4, 4. Then we have oxygen and sulfur, -2, -2. Okay. And after this one, we have nitrogen. Nitrogen -3 and phosphorus -3. Okay. And then fluorine, chlorine, bromine, iodine. They have -1, -1, -1, -1. So please copy this one fast. Everybody, please copy this one fast. That they are going to have the same. This is barium +2. Copy this one. When you're done, please let me know. Please copy this one. Aisha, Abdul Jabbar, you understood this one? Mariam?
Yes, sir.
Abdul Jabbar, you there in the class? You are muted.
Yes, sir.
Abdul Jabbar, are you there? And Aisha, you got it?
Yes, sir.
Okay.
Sir, done.
Now you noted this one, everybody?
Yes. Yes, sir.
Okay. So these are the important chart, very important chart that you must memorize, that everyone has to memorize this one. Okay. That for example, if this is sulfate ion, okay, SO4 -2. So if I ask you to write the formula of calcium sulfate, so what's the formula of calcium sulfate? What's the formula? Tell me.
CaSO4.
CaSO4. How can you write the formula for this one? Abdul Jabbar, you there in the class? Otherwise, I'm just going to inform your parents that you are not responding in the class. You have calcium is. So both when they are same, they will cancel out each other and they will have calcium sulfate formula as this one. Okay. Tell me the formula of calcium hydrogen carbonate. With this table, this is hydrogen carbonate, calcium hydrogen carbonate. What is the formula of calcium hydrogen carbonate? Tell me. What's the formula for the calcium hydrogen carbonate?
CaHCO3 2.
CaHCO3. Yeah. What you are going to
CA.
write? That calcium hydrogen carbonate. If I talk to calcium hydrogen carbonate, okay, so you will write calcium as Ca 2 positive and hydrogen carbonate as H minus 1. Okay, because hydrogen carbonate has valency minus 1. Okay, hydrogen carbonate has valency minus 1. So you will do cross multiply. Don't write minus and plus. It is not going, means it does not have any meanings. Means have the meaning, but plus and minus sign do not bother you. Okay, so just write when it is 1 here, we don't write anything here. Okay, then we'll write HCO3 and then okay, hydrogen carbonate, and this 2 will come because this is a polyatomic ion. What is this? This is the polyatomic ions, and polyatomic ions means it is going to, when we have polyatomic ion, it is going to multiply by 2. You got it? You got it?
Yes, sir. Yes, sir.
Okay. Yes, sir. Do this. Write down the formula of, I'm having some question over it. Just a minute. And then you have to write the chemical equations. I'm just writing the word equations. You have to write it in the form of chemical equations. Okay. Okay. Got it?
Yes,
So
sir.
just a minute. Just give me a second. Just a minute. Here we have this NCERT questions. Write down the formula of calcium hydroxide. Let me paste that one also here. Okay. What is the calcium hydroxide? When react with carbon dioxide, it will gives you calcium carbonate in water. Similarly, zinc when react with silver nitrate, it will gives you zinc nitrate plus silver. So write down their formulas that you required. Okay. So please write down the formulas of for calcium hydroxide. If you are facing any problem, so I am just pasting this chart here so that you can understand it more betterly. Just a minute. Because I think you have not memorized this one. So this is. So here is this chart. Okay.
So only calcium hydroxide?
Not only calcium hydroxide, the everyone. This is the chart here. Okay. On the screen. So please note it down. Everyone. Calcium hydroxide when react with carbon dioxide, what will be the chemical equations? It will gives you calcium carbonate in water. What's the formula of calcium hydroxide? Tell me. Calcium hydroxide.
CaOH2.
CaOH whole twice. OH2 is nothing. OH whole twice. Okay. So what we're going to write here is, because calcium has valency what? Calcium has valency. Tell me what's the valency of calcium?
+2.
Yes, +2. So you will write calcium hydroxide will have the formula Ca has 2 valency and hydroxide is this one. This is one is hydroxide. Okay. This has valency -1. This 4 is of ammonium ion. Okay. This 4 is of ammonium ion. So this is only -1. So you will write OH is -1. Okay. Then you will cross multiply this one. One is not going to multiply. You will write CaOH whole twice. Calcium hydroxide formula. Carbon dioxide, everyone know that it is CO2. Calcium carbonate. Formula of calcium carbonate. What is the formula for the calcium carbonate? Tell me. Formula for the calcium carbonate.
CaCO3.
Yes, CaCO3, because calcium has valency 2 and carbonate group has also valency 2. Where is carbonate group? This one is carbonate group. This one is carbonate group. Okay. So this carbonate group is going to have valency -2. We don't write 2 minus 2 plus 2. Okay. We just write 2 only. So this 2 and 2 will get cancelled out each other. We will have CaCO3. Okay. The formula will be CaCO3. Got it?
Yes, sir.
And plus water. Water, everyone know that water is H2O. So how can we write this chemical equation? Balancing is a different thing. We will learn it later. But first we will know that how to write the chemical equations. So this is calcium hydroxide when it is reacting with CaOH whole twice, when it is reacting with water. Calcium hydroxide when react with carbon dioxide, it will gives you calcium carbonate CaCO3 plus water. Okay. So this is the way that you are going to write the word equation with the help of this chart. Okay. Next, zinc when react with silver nitrate. So when there is a metals, let me tell you that when they are metals and non-metals, what are non-metals? What are non-metals? Tell me first, what are metals and what are non-metals? Tell me. Metals are those elements or that has 1 or 2 or 3 electron in their outermost shells except the hydrogen and helium. Like we have, what are metals? Like lithium, sodium, potassium, beryllium, magnesium, calcium, boron, aluminum. They are generally will consider to be as, except the boron, aluminium. Okay, they are generally considered to be as metals. So metals are always written in the individual form. Like for example, zinc react with this one. So we will not write zinc Zn2. Zn2. Zinc is a metal. Calcium is a metal. So these are metals. Like these are all metals. Okay. So I'm just marking this one. These are all metals, dear student. These are all metals. So whenever they are just going to write like magnesium react with this, so we will write only Mg without the charge. Without the charge. Charge will be only applicable when they are combining or when they are forming the bonds with some other elements. Like here, calcium has positive 2 charge. Okay, because it is combining with this hydroxide ion. But if I write calcium when react with hydrochloric acid, calcium when react with hydrochloric acid, so hydrochloric acid is HCl. It will gives you calcium chloride. Now it will be CaCl2. Calcium chloride formula is CaCl2. Why? Calcium has 2 valency and chloride ion has 1 valency, -1. Where is chloride ion? This one is chloride ion. This one is chloride ion. So -1. So it will be going to have the formula CaCl2 plus hydrogen gas. So hydrogen gas exists in the form of H2. So you have to memorize this when you keep on learning the chemistry. This is the first day of the chemistry or second day of the chemistry. So when you keep on learning the chemistry, then you will learn the things that how we are just going to write. Like for example, if you are going, if you are having a job interview, okay, and you are just selected in a company. So all the rules and regulation you are not going to learn in the first day, first or second day. You just keep on learning when you just keep on going there. You just meet the people, they will help you to that this thing happens like this way, this thing happens like this way, this is written like this way, this work has to do like this way. So when you keep on going, for your job, you will learn each and everything there. That is how to, that's like I'm teaching you. I know that how to teach you what at what time I'm going to teach you what topic I should teach you. So when I just keep on practicing this one, I learn each and everything. The similar thing is that when you keep learning the chemistry, this is not the first day that or the second day or the third day or the week or a month. I'm just saying it will keep on learning process. After 2 or 3 months, when you keep on going classes, then you will be learning and there will be a great change in the chemistry. I even say in a month or a week or a 2 week, you are not going to get everything in the chemistry. Chemistry is a difficult subject, not because chemistry is learned by each and everything, because it is started from the basics portions. You must know that what are electrons, what are protons, what are atomic structures, what is electronic configuration. So As you keep on moving, as you keep on practicing the things, you will learn each and everything. So it is not a difficult task. So here, why I write HCl? Because H, when hydrogen react, hydrogen has valency 1 and chloride and has valency -1. So it is HCl. HCl. Why I write H2? Because hydrogen is a non-metal and non-metals are always written as H2. Like if it is written in individual form, like Cl2, like Br2, like I2, like O2. S, sulfur is always written as S. Sulfur is element which is written only single. Like the metal, it is also written as single. Sulfur alone. Like magnesium written Mg. Okay. Like calcium here is written as Ca only. Okay. So similarly, coming to the question here is that zinc when react with silver nitrate. So you will write zinc like this way. Zn, not Zn2, because zinc is a metal. Okay. Metals are written alone. Metals are written alone. And when they are written alone, they are not written with the charge. They are not written with the charge. They are written alone. You understood? Understood? So
Yeah.
when it
Yes,
is
sir.
when it is going to react with silver nitrate, AgNO3. Oh, I have told you formula. So what's the formula of It's silver nitrate? It is AgNO3. Why? Because silver has valency 1. You can check it here. Where is silver? Where is silver? Silver. This one is silver. Okay. Ag. So it has valency 1. And nitrate, NO3. Where is NO3? NO3 is this one, nitrate. This one is NO3. Okay. It has valency -1. So one is +1, another is -1. So they both are combined. Both have same valency 1, 1. So they will form AgNO3. So zinc when react with silver nitrate, AgNO3, it will gives you what? Silver nitrate. Sorry, zinc nitrate. So what should be the formula of zinc nitrate? Tell me. According to this chart, what should be the formula of zinc nitrate?
ZnNO3 the whole 2.
Yeah, it will be zinc nitrate. The zinc nitrate is going to have formula because zinc has valency 2. You can check it from here. Valency of zinc. What is the valency of zinc? Zinc is here. Okay. So zinc is here. It has valency 2. Okay. And nitrate has -1. So when it has 2, another has -1. So what it is going to have? -1. So you have to cross multiply this one. 1 is not written. So you have zinc. Don't write 1 here. And then NO3, because N, it is a polyatomic ion, then we have to write it in the brackets. Nitrogen, oxygen, there are 2 elements are present here. So we have to write it in the bracket and we'll write it ZnNO3 whole twice. Okay. Got it?
Yes,
Yes,
sir.
sir.
Similarly, so this will be, the formula will be ZnNO3 whole twice. Zinc nitrate will have formula zinc and plus what? Ag. Now again, Ag, if it is written silver plus silver, it is saying plus silver. So when silver is written alone, it is not written as Ag2 or Ag1 positive. It will not be written like this way. It will be written alone Ag. The elements will have charge only when they are combining with some other elements. When they are making bonds. They don't have charge when they are written alone. And metal, since Ag is a metal, it will not be written like hydrogen H2. No, it is not written as Ag2. No, it will not be. It will be written simple. Okay. You understood?
Yes, sir.
Yes, sir.
Then next one. Barium. Write down the next one. Barium chloride when react with potassium sulfate. Abdul Jabbar, are you there?
Sir, aluminium plus copper chloride. How do we know if we have to use copper cupric or cuprous?
Yeah, it is important. Then when it is only written as copper and it is not mentioned to you, then we will go to the copper as +2 valency. Copper has +2 valency. The stable state, the most stable valency of copper is +2. Out of +1, it has +2. So when it is written copper, like copper has two valency. Just concentrate here, dear students. It is important that when copper has, Cu. Okay, copper. So copper has two types of valency. When it has Cu1 positive, then it is cuprous. Cuprous. Okay, its name is cuprous. When it has +2, its name is cupric. Cupric. We called it cupric, like cupric oxide. If I'm going to write the formula of cupric oxide, it means we have to take the valency of copper as 2, and oxygen has also 2, so it will cancel out each other. You will get CuO. Formula is CuO. Okay, and CuO. And when I'm going to ask you that cuprous oxide, cuprous. So when it has valency 1, its name is cuprous. Okay, and its formula will be 1 copper and oxygen is 2, so it will cross multiply here. So we will get Cu2O. One we are not going to write here. Okay, so it will be Cu2O. Now, neither it is written cuprous nor it is written copper. Sorry, cuprous nor cupric. It is only written copper. So when it is written copper, then we will go first preference to the oxide or cupric. Okay, so we'll say that it is cupric or copper. So if it is not mentioned to you that as cupric, so it is copper. Okay, you understood?
Yes, sir.
Yes, sir.
Okay. So similarly, dear students, so what should be the formula for the copper chloride?
CuCl2.
Aluminium, yeah, CuCl2. So aluminium will be written as single alone. Aluminium when react with copper chloride. So copper chloride will be, copper has valency 2 and chloride ion has valency 1. So you cross multiply, you will get CuCl2. And when it react, it will gives you aluminium chloride. So what's the formula for the aluminium chloride? For the aluminium chloride,
AlCl3. AlCl3.
AlCl3 plus copper. So will I write copper like this way? Cu2 positive?
No, just Cu.
Only the Cu, okay? Because it is written alone. When it is written alone, so it will be written like this way. Okay? So this is the formula for this one. Okay? Next, if I ask you barium chloride when react with potassium sulfate. Barium chloride when react with potassium sulfate. So write down the formula of barium chloride first in your copy, then potassium sulfate, then barium sulfate, then potassium chloride. Write all the formulas, please. With the help of this chart, finding this one, where is barium? Barium is not written here in this one. So write down barium. Barium has valency 2. Write in this 2. Barium has valency 2 positive. Okay. Barium is Ba and its valency is 2 positive. Note it down. Ba single, or it is having single. Barium. Ba2 positive. Note it down, please. What's the formula for barium chloride?
BaCl2.
BaCl2. Yeah, it will be BaCl2 because barium has valency 2 and chloride has 1. So it will be BaCl2. BaCl2. Why? Because it has 2, like we have Ba2 and chloride has 1. So you cross multiply, you will get BaCl2. When react with BaCl2, when react with potassium sulfate. Potassium sulfate. What's the formula for the potassium sulfate? Write down the formula.
K2SO4.
Potassium sulfate is K2SO4. K2, where is K? Potassium is this one and sulfate is SO4. Sulfate ion is this one. This one is sulfate ion. Okay. So K, potassium 1 and sulfate is SO4. S2. To cross multiply, we'll get K2. You will get K2SO4. We'll get K2SO4. K2SO4. So it is correct, K2SO4. Then barium sulfate plus barium chloride.
Barium
K2,
sulfate is BaSO4.
yeah, barium sulfate will be BSO4 because both have 2. This has 2, this also has 2. So you cancel out each other, BSO4 plus potassium
Chlorine
chloride,
chloride,
potassium
KCl.
KCl. Why? Because it has 1, it also has 1. So it will be KCl. Okay, now you understood that barium chloride, BaCl2. Okay, this will be barium chloride will be BaCl2. Okay, so it will be when it reacts with potassium sulfate, K2SO4, it will gives you barium sulfate BSO4 plus KCl. Okay. Okay, everyone.
Yes, sir.
Now moving to the next part is just a minute. Write down this one. Write down this one. Potassium bromide. I'm just writing potassium, the element used. Potassium has +1, bromide has -1, barium has +2, iodide has -1. Okay, then you can use this one. Zinc carbonate, zinc has +2, carbonate has -3, sorry, -2, and again oxide has -2. Okay, hydrogen H positive, chloride Cl minus. Okay, so I'm just writing the name only of those that will be used in this one. Magnesium +2, hydrochloric acid is HCl. Okay, magnesium is +2, chloride is -1. Here it is, and hydrogen is +1. It is. So write down all, but do it fast, please. Write down all the chemical equations, please, with the help of this element that I have written here. Ba is barium, potassium, bromine is Br -1, iodide, carbonate is -2. So write down, please, this one.
Done, sir.
You done this one?
Yeah, all done.
All done. Okay. So how can you write this formula, that is potassium bromide, barium iodide, potassium iodide, and barium bromide? So how can you write this one? At potassium
KB,
bromide, yeah, potassium bromide is KBr,
KB,
KBI, sorry. K, bromide is Br, bromide is Br. So it will be
KBR.
KBr, KBr, because both has 1, 1, potassium and bromide has 1, so it will be a KBr. Then barium iodide. So Ba is 2 and iodide is 1. So when it is having this one is 2 and this one is 1. So cross multiply this.
BaI2.
Yeah, it will be BaI2. Okay. And then
Potassium iodide is Ki.
Ki plus
BrBa.
okay. Then we have barium bromide. Barium bromide will be BaBr2. Barium bromide will be BaBr2. Why? Because barium has valency 2 and bromide has valency 1. So cross multiply BaBr2. Okay. So KBr when react with BaI2, it will gives you potassium iodide plus BaBr2. Okay, you understood?
Yes, sir.
Yes, sir.
Next one is zinc carbonate. What's the formula for the zinc carbonate?
ZnCO3.
ZnCO3. Because both has two valency, it has 2. It has also 2. They both combined together. ZnCO3. Okay, when react with zinc, when it is heated, it will gives you zinc oxide plus carbon dioxide. So zinc carbonate